Hi, in this video we are going to see about anti-logarithmic amplifier. Already we have discussed something about a logarithmic amplifier, and now what is anti-logarithmic? That is, input is the logarithmic value. For that input we are getting a original output, that is anti-logarithmic operation. Okay, this is what a structure. Sorry, I have forgot to explain about the structure in a logarithmic amplifier. So we have seen only up till this. That is, here we are having a three operational amplifiers in this structure. Sorry, four operational amplifiers in this structure. So the same operation can also be done using only the two operational amplifier. So this is what a logarithmic amplifier structure with only a two op amp. So the same here we are having the same structure as A1 and A2 is all the same one. Only changes in this connection. Here we are having a connections and here we are having a connection. So this one acts as a feedback. So this is what a structure where the same operation of the structure with a 4 op amp can be done using a 2 op amp. So next one, the same this two op amp structure is used for the anti-logarithmic amplifier also. So here comes a change. What is the difference between the logarithmic structure and anti-logarithmic structure means? This is what a logarithmic structure and this one is an anti-logarithmic structure. So what is the difference we can find out in this diagram is only difference is here we are having an input given for the op amp, whereas for this op amp the input is from the output, so it is a feedback. So this is what a first difference. And second difference is here for this anti-logarithmic structure, input is given in this position. That means in this point in the logarithmic amplifier. So that is given as to the input through this, and through this we are having received the. So in this way we are receiving the output. So here it is an reverse structure. So this is an anti-logarithmic structure. So let us see a derivation of this anti-logarithmic amplifier. Now it's same structure we are considering. We already know the equation for the logarithmic amplifier. So in this, let us consider this one as an output for this A1 operational amplifier. Logarithmic output is what? Similarly, for this A2 operational amplifier, what is the logarithmic output? So for that, here we are having what is output at the VQ1 base to emitter of this transistor. So that is KT by Q ln of V0 divided by R1 into IS. Similarly in this transistor also, we can write KT by Q ln of V reference divided by R1 divided by IS. But what is the condition is here in the Q1 transistor, here in this Q1 transistor the base is connected to the ground, so we are considering it as a negative, here it is a positive. So VA, this point, so this point is connected to this, so we can write VA is equal to minus of VBE. So that can already we know that it is equal to KT by Q ln of, so minus of KT by Q ln of V0 divided by R1 into IS. Since V0 is the input for this circuit, so it is V0 divided by R1 into IS. So the same thing, base voltage of VB. What about the base voltage of VB? Here this VB gets the input from this input V1, where this connection, in this connection here VB is across this resistor. So here it is in parallel connection. So here across which resistor input we are giving, sorry, it is a series connection. So input we are giving for a VI. and across this resistor we are going to consider the output, that is a VB. So it is a base voltage divider bias, voltage divider rule we are considering. So across which resistor divided by the total resistor into the source voltage is VI. So we can write this emitter voltage. While considering this V reference also, we are having some voltage effect here. With the respect to VB also, we are having a voltage in this point. So what is this voltage in this point? So voltage at that emitter voltage in Q2 is equal to that is due to the VB and also due to the V reference. So this is what due to V reference and this is what due to VB. So applying this, what we can write is, here we are having VA. So VA is equal to voltage at this emitter. So previously we have found a value for voltage at the emitter point in a Q2 op amp, Q2 transistor. So this is equal to VA. So in the previous slides we found what is VA, right? So what is VA? Here we are having VA is equal to minus KT by Q ln of V0 divided by R1 into IS. Similarly, VE is equal to this RTC divided by R2 plus RTC into VI minus KT by Q ln of V reference divided by R1 into IS. So we are equating these two equations and we are finding the value of RTC divided by R2 plus RTC into V1, right? So here we are having KT by Q, it is a common in this KT by Q, here also AT by Q. Rearrange the equation and bring it to the one side. So it is V0 divided by R1 into IS minus ln of V reference divided by R1 into IS. So here it is ln A minus ln B. So in this we can write it as ln A by B. So that is this R1 and IS will get cancelled in that. So we are getting only the final one. So at last, that is ln is equal to V0 divided by V reference. So now we are taking a natural logarithmic. So what is the relationship is log value is equal to 0.434 into ln. So this equation is in terms of ln. We have to convert it into logarithmic. So that means what we have to do means multiply this side and also the right hand side and left hand side by means of a 0.43. So by that we are getting a value as 0.43 into ln, that can be replaced by logarithmic. So here 0.43 into ln, this can be replaced by means of logarithmic, and this entire term is considered as a k. So this is what minus, that is k dash. So what is k dash? The entire term is considered as a k dash. So now this equation we can rewrite. So here it is k dash V1 divided by this. So if we take a exponential on both sides, that is exponential of minus, that is a k1 k dash Vi is equal to log and exponential will get cancelled. Finally V0 divided by V reference is the equation. So bring it to this side. So this is what our final value. So that is V0 is equal to output is equal to exponential of input. So this circuit is also called as an exponential amplifier. So what it means, if we change the input by means of at least one voltage, so there is a main difference occurs at the output. So small change in the input, it has a drastic changes in the output, so it is called as an exponential amplifier. Thank you.